Hello again, and we're going to talk about limits some more this week. If you haven't already watched the lesson on secant and tangents, I would recommend that. We introduced the idea of limits there. And here we're going to talk about them using a graph. So this is our first lesson that we're going to do from Chapter 2, Section 2. If you don't have a graphing calculator with you right now, go grab that. Pause the video, go grab that before we get started. Here, we're going to start by defining what a limit is, and this is how the limit looks. It's going to be LIM, which stands for limit, as x approaches some number of a function of x. So this could be x squared, this could be something kind of funky like what we see over here, could be sine, whatever the function is. And the way that we read this is we say the limit as x approaches a of f of x, and what it means is what number f of x approaches as x approaches a. So I find this is definitely a concept that makes more sense when we look at a graph. So here, we're going to use this graph of what's called a piecewise function, because we have different pieces here, to find these limits. So the first one asks, this is the limit as x approaches -1. So if I look at the graph here, -1, this is our x value that we're going to be approaching. And if I look at the function around -1, here, this is what the function is doing around -1. And so we can tell the function is approaching this point here. And so that is the limit. So in this case, we would say that the limit as x approaches -1 is equal to 4. And it will often just be a number like this. It's like, okay, well, the function, if we're looking right here, we're going along the function around this point. Oh, the limit's 4. And the nice thing about that is you notice that was a colored in point. This same thing will happen if I'm looking at, let's say, x as x approaches 4. Now, if you go over here, you'll notice that when x approaches 4, it's actually a unfilled in point. F of x doesn't actually exist at x equals 4, but the limit does, because as we go closer to that point around this interval near 4, we're still ending up with a limit. And that limit is, in this case, 2. So you're just looking at what is the graph approaching? What number are we getting close to? Now, these two are nice examples where we have very straightforward numbers. Now, if we look at something like x as x approaches 2, 2 is here. We're looking here. If I'm looking at the graph close to 2, if we're looking at this side, we're ending up here, but if we look at the other side of that interval around 2, we have two very different behaviors. We are approaching two different numbers. And so in this case, the limit as x approaches 2 doesn't actually exist, because on this case, we're approaching -1, but on this one, we're approaching 5. And 5 does not equal -1. And so the limit at that point does not exist. You might remember something like this from a very classic old movie of my generation called Mean Girls. Now, the nice thing that's happening here, though, is if you were like, well, the limit over here exists, and the limit over here exists, they just aren't the same. And you can actually have this. These are called one-sided limits. So it's where we're only looking at one side of the function versus the other. So both of these one-sided limits exist, but the whole one doesn't exist. Now, the way that we think about this is that there are two options. There is a left-hand limit, which we show by putting a little exponent of a negative sign, meaning that it is the limit as we're coming from the negative numbers towards a. And then there's also a right-hand limit, which is shown with having a little exponent of a positive sign, meaning that it's coming from the positive direction towards a. So if I'm looking at this picture here, this is asking what's the right-hand limit, so I'm coming from the positive direction, which would be this one. And the right-hand limit here is 5. Because we're only coming from this direction and it approaches this number here, 5. On the other hand, the left hand, as we come from the negative side, this limit is approaching -1. And so the left-hand limit with that negative-looking exponent is -1. Now, these are all problems where you have the picture already made. Now, there are going to be some where they just give you the function and you want to graph it yourself. And the best way to do this is, of course, to grab your calculator. And the first thing we want to do with our calculator is type in this graph. And when you type it in on the graph, what you want to do is you want to put parentheses and type in the numerator. So parentheses x squared minus 2x, close parentheses. And then put your division sign. It might also be just a line like this. And then another set of parentheses, x squared minus x minus 2. So make sure you're typing it in like that so that you get the correct answer. And then we're going to look at the graph. And this should be similar to the graph you get. Some of you might not have this line here. That's fine. It's just a setting on your calculator. You don't have to worry about it right there. But one thing that you should know is that this is actually a vertical asymptote. So it's not actually there, your calculator just draws it in, but this is a dotted line that the function is approaching. So here we're asking, if we're looking at this graph here, the first thing it asks is, what is the limit as x approaches -1? Well, -1 is, it's right here. It's right at that asymptote. And if you look at it as the graph approaches -1 from the negative number side, or the left-hand side, it's going up forever. And from the positive side here, it's going down forever. So they're approaching two different directions. So this means, just like in the previous example, this doesn't exist. Now, as we said, there are left-hand and right-hand ones. If I'm coming from the positive direction here, you see how it's going down forever and ever and ever? That means it's approaching negative infinity, and you are absolutely allowed to write negative or positive infinity. Now, sometimes if we're asking for a number, a numerical answer to plug into a problem, and you get positive or negative infinity, such as for this one, it would be positive, as it comes from the negative side, sometimes you will have to treat these like they are DNE because they aren't numerical, but it does say something about its behavior of the graph. So go through these problems from the first set of 2.2 using your calculator and just looking at the pictures. There's not going to be a lot of shown work for these problems. And let me know if you have any questions in the comments below or set up a meeting. I'll talk to y'all later.